So in this practical demonstration, we'll use an example called as breast cancer dataset. So this comes with the sklearn datasets. So this is basically a classification kind of a dataset that is used for classifying various patient data samples that was made it available for learning purposes. And then the data would be classified for either it is a malignant cancer or a benign cancer. So that is a kind of a classification example. So we may not go too deep into the data set itself, but the purpose of this exercise is to understand how the minimal complexity cost complexity pruning can be done, right? So it is about the theory that we have done on different alpha values and how that influences the impurities and whether we can find a better pruned tree. So that's the overall objective. So let's go ahead and understand this. So I'm loading the breast cancer dataset here, and I'm gathering the X and Y values from this, and we are doing the train test split using some random state here. So if let me execute this, and you can also find some details here. When you execute this code, you'll also know about this dataset and what this dataset has, the type of features that it has, and so on and so forth. So please definitely explore it, but I think this is less important for this particular exercise, right? Then what we are going to do now is we will first build a classifier, which is the decision tree classifier. Remember, this is a classification problem, so we are building this. And then we have a method called as cost complexity pruning path. For the same classifier object that we have built, there is a cost complexity pruning path method, which takes the training data, input training data, and the output training data, which is X train and Y train. Given with that, it is going to understand, right? It will try to experiment with various alpha values, and so basically it measures the effective R alpha for the respective subtree with a pruned set of nodes, right? So that's what it is going to do. So let's go back to the code. And so this is what this particular method is going to give us into this path variable. It is going to give us both the CCP alphas, which is remember the cost complexity parameter, and the impurities for the respective alpha. So both of them would be given into this particular object. So we are capturing it into two different variables, which has alphas and impurities separately, so that we can also visualize it. So I'm just trying to get it into the data frame, and I'm printing it here. So let's run this. Right, so if you can run this, it is actually printing us the various alpha values and the respective impurities, right? So it started off with 0, which means there is no pruning done, right? Alpha being 0 means the impurity is also 0 for that. But as we are actually changing different alpha values, you can see that the impurity has been rising, right? So the highest impurity is obtained when we have a CCP alpha of this much, right? And we don't want the highest impurity also. And we neither want the lowest impurity, because the lowest impurity we have been suspecting, and it is very likely the case that it will be a overfitted scenario, right? So we will try to understand how these CCP alphas, if we train the decision tree with these alphas, how do they do on the testing data as well? So that's what we want to know. So we want to figure out, what we will do is we will have a impurity for training. This is impurity for training data. Now for all these alphas, we will measure the impurity for testing data also. So that's what we're going to do in the next step. So once we do that, we will then figure out which is a better one by probably plotting it and by visualizing it better to see what is the right alpha that will do effectively on both the data sets. So moving ahead, so what we're doing in this step is for each of these CCP alphas, sorry, I think here we are trying to also plot this the same data frame that we have seen here. We are also trying to visualize it through a plot graph here. So here on the x-axis we have various alpha values, and on the y-axis we have the impurities. So the same thing that we have seen here, I'm just trying to plot it using the matplotlib, right? So I'm passing the x-axis for the CCP alphas and y-axis as impurities, right? And then we're setting the label, title, so on and so forth. So in the previous videos I have explained how to plot using matplotlib. So I'm sure you could also find more details there. Now in the next step, what we are doing is for each CCP alpha, right, we have captured various alpha values. For each CCP alpha, we are building a decision tree classifier, right? Why are we building it? Because we want to measure it with testing also this time. But earlier what we have done is this has only outputted us. It has not created the classifier, right? It has only given us the possible CCP alphas and impurities using the various formulae that it has actually, we have seen earlier, and it has determined, but it has not really built the full classifier. So now we are doing the classifier building with those alphas, right? So for each value we are building a classifier model with a random state and the CCP alpha, right? And then we are fitting it with X-train and Y-train. So that means we have initialized the model and we have been training the model with the alpha, right? And we are appending it to an array. So this is an array, empty array, and in this loop we are appending it to array. So at the end of this loop we will have an array of decision tree models, with each model corresponding to a different alpha value that we have seen, right? So with that, what we will do in the next step is we will try to visualize different CCP alphas and what are the node counts, right? What is the depth that CCP alpha has picked, right? So what we are doing here is for each remember we have created a array of classifiers here, right? So for each classifiers, right, for CLF and CLF, so that means for each model we are taking the node count. CLF.tree_.node count will give us the overall node count here, right? And like that we also have a max depth parameter, right? That is the depth of the tree. So that means for each of the classifiers we are getting the node counts and depths into a different array so that we can visualize it. So the whole purpose, why are we extracting it separately, is because I want to get a plot out of it, right? So we are basically doing two plots here. One is CCP alphas to node counts, one is CCP alphas to depth. So this is again just for us to understand. So I'm missing something here. I didn't run this one. Okay, so I've run this code so that the array is built. Now we can run through this as well, right? See, now if you can see the alphas on the x-axis and the number of nodes on the y-axis, right? If the alpha is 0, we got the highest number of nodes, and as the alpha is rising, it is pruning. It is pruning various nodes, and the number of nodes is really going down, right? So at this level of alpha, the impurity is the lowest. At this level of alpha, the impurity is highest because there is only very less number of nodes. That means, we will be left out with probably the root node or maybe one or two other nodes, but otherwise with just those one or two nodes, I'm sure we know that we won't be able to predict well. We don't have enough decisions to make out of only those two nodes. So again, our objective is to find out the best place where it does well, right? So this is still with the training data, but I'm just trying to show you how this is visually showing it for us, right? And then in this one we are also visualizing something similar to the depth of the tree. Very similar, as the node count is reducing, the depth is also reducing. I think this is self-explainable, but we can understand how alphas is effectively reducing the various alpha values, is reducing the number of nodes and depth of it, right? So the next thing is that this is the final step where we will really understand how various models that we have built with various CCP alphas, how do they do on the testing data, right? This is the final plot using which we will understand how the training impurities are and how the testing impurities are, right? And then we will figure out which is the best one. So for that, again, we are looping through all the models, and for each model we are getting a score of it, right? Remember, the score would give us the accuracy score for for this decision tree classifier, right? Since it's a classifier, we use the score, and of course in the case of regressor, it will give us an R² value, right? So we will measure the score for each model for the training data. Remember, this is for the training data, and we are getting it into train scores, and we will do the same thing with testing data this time, right? So far we have been exploring more from a training data point of view. Now we will also get the scores for testing data for these models. Right? This is the true test for us, right? For all these models with various CCP alphas, we will get train score as well as test score, and finally we're just plotting it, right? We have this plot with CCP alphas and train scores, and CCP alphas and test scores, right? And by plotting this, we're going to see how the how the impurities the accuracy, right? The accuracy is the measure, the performance of the model, right? How the performance of the model has been as we are actually increasing the alpha values here. So as you can see, at an alpha of 0, the training data accuracy is the highest, but accuracy is very low for the testing data, right? So this is what we were thinking. This is a overfitting scenario where the model is doing very well with the training data, but it is doing poorly with test data. So but as we are increasing the alpha here, you can notice that the training efficiency is reducing. That means the model is doing slightly compromising with the training data, but the important thing to notice here is the testing accuracy has been rising really well, right? You can see that as it is going from 0.05 to the next levels, it has really sharply increased, and so on. So we can see that it has increased until this level, right? After between 0.1 to 0.15, so probably around this 0.15 range, it is actually flat. But this is where we can see that both training and testing accuracy is reasonably well, or in fact which is the best that we could get, considering the known alpha values and the performance, right? We got about 0.997 performance on the training data and about 0.94 on testing data, I think, which is pretty healthy, and which is also backed up by statistical formulae and statistical methods that we have understood, right? So that's pretty much what I wanted to cover here, right? How the cost complexity pruning, how do we experiment with various alpha values, CCP alpha values, and finally understand which alpha value to pick up. All right, so thank you so much. I will see you in the next video. Have a good day. Thank you.